Hey there, science fans. Let's talk about something we use every day, light bulbs. Imagine a world without them. Dark, right? Before electric light, people relied on candles, oil lamps, and gas lights. These worked, but they were messy and dangerous. Then came Thomas Edison and his incandescent bulb in 1879. Edison's invention revolutionized how we live. Suddenly, we could have light at any time, in any place. It was a game changer. But the story of the light bulb doesn't end there. In fact, it's still being written today. Let's explore how these amazing devices are made. Over the years, light bulbs have evolved. We've moved beyond Edison's incandescent bulb to embrace new technologies. Today, we have a variety of light bulbs to choose from. Incandescent bulbs, the classic choice, but not very energy efficient. Compact fluorescent lights, or CFLs, curled like pigtails, they use less energy than incandescents. Light-emitting diodes, or LEDs, these are the most energy-efficient and long-lasting option. Halogen lamps, similar to incandescents, but brighter and with a longer lifespan. Each type has its own manufacturing process. Let's shed some light on how they're made. The original light bulb still shines bright in many homes. Making an incandescent bulb is a delicate process. It starts with the filament, usually made of tungsten. Tungsten can withstand very high temperatures without melting. The filament is wound into a coil and attached to two wires. These wires are then embedded in a glass mount. The mount holds the filament in place and connects it to the base. The glass bulb is then sealed around the mount, creating a vacuum or filling it with an inert gas. Finally, a metal base is attached. This base allows the bulb to screw into a socket, completing the circuit and letting the light shine. CFLs, with their curly design, are a leap forward in energy efficiency. Making them is quite different from traditional bulbs. It starts with a glass tube. This tube is coated on the inside with phosphor powder and filled with a mixture of argon gas and mercury vapor. Next, electrodes are attached at each end of the tube. These electrodes allow electricity to flow through the gas, exciting the mercury vapor. When the mercury vapor is excited, it emits ultraviolet light. The UV light is invisible to our eyes, but the phosphor coating on the tube converts it into visible light. This is why CFLs have that distinctive white glow. The tube is then bent into its signature spiral shape, making it compact and efficient. Section 5. Light. Emitting diodes, a revolution in illumination. LEDs are the future of lighting. They're super energy efficient and last much longer than other bulbs. Making them involves semiconductor technology. An LED chip is a tiny piece of semiconductor material. This material is doped with impurities to create a PIN junction. The PN junction allows electricity to flow in only one direction. When electricity flows through the junction, it causes the electrons in the material to jump to a higher energy level. When these electrons fall back down to their original energy level, they release energy in the form of light. The color of the light emitted depends on the type of semiconductor material used. The LED chip is mounted on a heat sink to dissipate heat and then encapsulated in a protective resin. Section 6. Halogen lamps, brighter and more efficient. Halogen lamps are like incandescent bulbs, but with a twist. They're brighter and more efficient, thanks to a special gas inside. The process starts similar to incandescent bulbs. A tungsten filament is enclosed in a glass bulb. However, halogen lamps use a smaller quartz bulb filled with a halogen gas, like iodine or bromine. The halogen gas creates a halogen cycle. This cycle redeposits evaporated tungsten back onto the filament, extending its life and allowing for a higher operating temperature. This higher temperature results in a brighter, whiter light. Halogen lamps come in various shapes and sizes, making them suitable for a wide range of applications. Section 7. The automatic factory automation in light bulb manufacturing. Making light bulbs, especially in large quantities, involves a lot of precision and speed. That's where automation comes in. Modern light bulb factories are highly automated. Robots and specialized machines perform many tasks, from winding filaments to sealing bulbs. Automation ensures consistent quality and increases production speed. It also improves worker safety by handling hazardous materials and performing repetitive tasks. For instance, in CFL production, machines precisely dispense the mercury vapor and argon gas mixture, a task that would be dangerous for humans. Section 8. Shining brightly quality control in light bulb production. Quality control is crucial in light bulb manufacturing. After all, nobody wants a bulb that burns out quickly or doesn't work at all. Throughout the production process, rigorous checks are in place. These checks ensure that each bulb meets the required standards. For instance, machines test the electrical resistance of filaments, the vacuum or gas pressure inside bulbs, and the light output and color temperature of finished products. Any defective bulbs are identified and removed from the production line. This ensures that only high-quality bulbs reach consumers. Section 9. Lighting the way to sustainability environmental considerations. The lighting industry is becoming increasingly aware of its environmental impact. Manufacturers are taking steps to make light bulb production more sustainable. One focus is on using less energy and reducing waste during manufacturing. Another is on developing eco-friendly bulbs, especially LEDs, which are highly energy efficient and long-lasting. Furthermore, proper disposal and recycling of light bulbs, especially CFLs containing mercury, are crucial to prevent environmental pollution. By embracing sustainable practices, the lighting industry can minimize its environmental footprint and contribute to a greener future. Section 10. The future of light challenges and trends in the industry. The light bulb industry is constantly evolving. New technologies and challenges are shaping its future. One major trend is the development of smart lighting systems. These systems use sensors and internet connectivity to optimize lighting usage, saving energy and enhancing user experience. Another challenge is finding alternatives to rare earth elements used in some bulbs, as their mining can be environmentally damaging. The industry is also exploring new materials and manufacturing techniques to further improve efficiency, longevity, and sustainability of light bulbs. So the next time you flip a switch, remember the fascinating journey of the light bulb, from Edison's invention to the cutting-edge technologies of the future.